Welcome back to the third video. In this video, we're going to graph two inequalities in two variables. By that, let me tell you what we're planning on doing. Our goal is to graph the first inequality. Just like on the last video, we're going to take the entire graph and divide it in half. The boundary that we're going to use is a dashed line because we can go up to two things that add up to 6, but not exactly 6. We can go as close as we can as long as we're less than. So once we divide it in half, we'll pick a test point and we'll shade 1/2 of the region. After we do that, we go back again and we do the exact same thing. This boundary is going to be a solid line because if those two things add up and equal 10, they'll be included. Again, we'll take a test point and we'll choose which side we're going to keep. If you look at what we just did, we've divided the graph into 4 regions. And in those 4 regions, we have one region that's been shaded twice. That's the intersection. Remember when we did Venn diagrams and we saw the intersection? The intersection was the area that was shaded twice. Whenever we saw an intersection, it always included the word and. This is the final answer to the problem. It's the region that's shaded twice. That was kind of a vague overview of what we're going to do. Let's actually do it. I'll do everything in green for the first line. That's where I'll start. I have x plus 2y is less than 6. My first thing I'm going to do is to draw the boundary. X plus 2y equals 6. To draw this, I could solve for y and do the y equals mx plus b, but something pops out at me. I can graph this using the 2-point method. If I can find 2 points on the line, that's enough to draw any line, and the x-intercept and y-intercept pop out at me. The first order pair is the y-intercept. That's when x is 0. When I put 0 in for x, y has to be 3. For the x-intercept, when I put 0 in for y, x has to be 6. I'll graph 0, 3, and 6, 0, and those 2 points will help me identify my boundary. Remember, because it's a less than, it's going to be a dashed line. Now I'm going to test a point because I need to either keep this half or this half of the graph. My test point will help me figure out which side to keep. I can pick any point, but I think I'll pick the point 0, 0. I'm going to take 0, 0 and put it back into the original inequality to see if I should keep this side of the graph. When I put 0 in for x and 0 in for y, that is definitely smaller than 6. So that's the side that I want to keep. I'll take and I'll shade this half of the graph. All right, halfway done. Let's do the other half. I have x minus 2y is greater than or equal to 10. Nope, sorry, negative 10. It's greater than or equal to negative 10. For this one, why don't we solve for y and find the solid boundary that divides them. I see that when I move the x over, I have negative x minus 10. When I divide all 3 terms by negative 2, I end up with y equals 1/2 x plus 5. This solid boundary crosses the y-axis at 5 and has a slope of 1/2. Up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2. I think that's enough points for me to be able to draw my solid boundary. Ignore the green part and you'll see that the blue line has divided the graph into two halves, an upper and a lower. I'm not sure if I should keep the upper half or the lower half. I'll test a point. The point I'm going to test is 0, 0. I'm going to take that and substitute that right back into the original equation. Is this point a satisfactory answer? When I put 0, 0 in, whoa, that's definitely not bigger than negative 10. Wait a minute. Think about it for a minute. Is 0 larger than negative 10? Yes, it is. This side does work. We definitely want that side. We don't want the upper half above the blue. We only want the half that's below the blue. So we'll shade that in. It looks kind of messy, but we're ready to interpret the graph. Remember, we're trying to find the intersection, the quadrant, the fourth, that's been shaded twice. I see that this area here contains all of the ordered pairs that have been shaded twice. That's my final answer. I can't express it with interval notation. Interval notation only works when there's one variable. I can't write those ordered pairs because that's a lot of ordered pairs. The way that I express the answer to this question is with a graph with 1/4, one region shaded. I hope that's clear to you. I hope that helps you do the rest of the skill practice problems in 9.5. If you need any help, be sure to ask. You can call me or email me. Great seeing you. Okie dokie.